Hey guys, this will be video 11 for the how to design build a 58 Explorer replica, painted sapphire blue, and shark fin mother of pearl inlays, and then do some wiring and layout and all that jazz. And I did just that for the Tessie kill switch. And so basically in this video, I'm going to be talking about the Tessie kill switch and how you would go about, laying out the pick guard in that location. And then I'll end the video by talking about the wiring harness that I've got in production. So basically, it has to be built in component form, and I'll show you kind of how I set up to do that when I'm building my own harnesses and stuff, and how to keep from damaging your guitar. And the short is just put the guitar in another room, and then just work off your templates until you know that you're ready for it to go in the body, because you're going to want to do the bulk of the wet sanding and all of the buff work. You want this guitar to be really beautiful and finished before you put the electronics in it or anything, because there's nothing more of a nightmare than having something like a potentiometer shaft sticking up while you're trying to wet sand it and wax around that. You just can't do it. It's got to be a raw body. Okay, so at the end of the job, you're kind of working in component form, but you're also working in tandem with doing the finish work as well as you're doing add-on work. So anyway, let's open up the Tessie kill switch, and well, I'll tell you what I did. Let me talk about the layout first, because I did video 11. I think it was Thursday night or Friday night, and it was like an hour and 5 minutes long. It was a really good video, but I felt like it was unnecessary, so I never even uploaded it. So let's back up to the ending of video 10, and I actually just watched video 10 so that I shouldn't be redundant in this conversation. But basically, what's kind of comical is video 10. I was still doing a lot of layout and asking Art questions. Hey, where do you want this thing? And here are your options to do this. But what's kind of comical, in the last email he had sent me, he had attached two pictures actually showing exactly where he wanted the Tessie kill switch and kind of his reasoning, and actually, well, kind of his exact reasoning behind why he wanted it right there. So I didn't see those picture attachments when I prepared for and then presented video 11. But it's not a waste of time, because everything that I went through in video 10 would be something that we as custom builders or building a guitar for ourselves, those are the things that we would want to be processing through. But it's kind of funny because Art had already told me exactly where he wanted it and why he wanted it there. So anyway, so it is what it is. And what I covered in the video that I never even uploaded was kind of the safe way about going about locating that hole and how to set it for it, how to offset. And what it really boils down to, rather than trying to use a template and measure and guesstimate all that stuff, just put some tape up on your body. If your body is real nice and dry, you wouldn't want to do this if you had just sprayed the lacquer. You run the risk of, once you pull this tape off, it separating. And a quick short, in case I forget, when you're removing tape, make sure you just roll it like that. And if it looks like it's going to be a little problematic, or if it's definitely in an area where it's not going to be covered, keep a little bit of mineral spirits up there and just drip some mineral spirits on it, and then help remove the tape. Okay, I shouldn't have done that, because now that's kind of screwed up. And then let me see if I can cut that loose. Sorry, let me pause for a second. Make sure it's rolling. Okay, so the short is, put the tape up there and then just lay your pick guard in place, get it exactly where you want it, and I mean spot on exactly where you want it, and then somehow or another fasten your pick guard in place. If you have to tape it, come around with a real fine pin and draw the perimeter, which I've got right there, And then I even went to the extent of actually drawing the locator holes of where the two little screws would be down here. There are no other screws. But basically what's going to be happening is the Tessie kill switch is going to be going to the left side of that hole that is machined right there. And then any of the wiring will come down and kind of circle around it a little bit and then continue into the control cavity. And in case I forget, the reason that paper's in there is when I was sealing it with some Nitro Cellulose lacquer, make certain that you shove some paper towel up in that hole, because when you're doing all your sealing, the Nitro is so thin, the last thing you'd want to happen is it to run out and then run across your body, because it'll be game over. You'll have to refinish the back, or it might be game over. You might get lucky and get away with it, but odds are you'll probably get yourself in trouble. Okay, so that's what I did. Put the tape up there and located everything. Excuse me. And then the way I drilled this was obviously that channel came all the way down to about right there. I really can't remember, or maybe it came all the way to the end. Regardless, I temporarily glued in a small block, and then with tape, and then I found the exact location where I wanted the Tessie kill switch, just based on this little template that I made that's 24 millimeter. And in case I forget, I don't know, I didn't cover this in video 10. Art, I had made a statement this Tessie kill switch is roughly like 28 millimeter on the outside, but Art had already sent me the info for the one that he had found, and it was 24 millimeter, and I didn't get to clarify. Yeah, it's 24 millimeter is based on the minimum size hole you need to cut in order for the kill switch to actually recess down in the cavity. But that would be the minimum hole if you were going to cut it up here where there's no wiring going around it. But since we're down here in this location, it literally was pretty much almost right in the center of the main wiring channel that, after it's all said and done, has a total of 3 wires coming from the three-way, and then 2 wires coming from the pickup. So that's the most congested area in the entire guitar, and the most congested area in order to locate that Tessie kill switch. So it just required a lot of layout and engineering. But every bit of this that got done, every bit of this work that got machined down here was simply based on this looking good. Okay, or not, well, not just that, but looking centered and looking like it was actually engineered in the location. But it's also based on the fact that Art had clarified to me, I want it pretty much in line with the bridge, because I won't be using it much, if any at all. But every now and then, if I do, I want to just be able to reach down and do the ditto work down there. And since I'm talking about the function and the layout, I'll go ahead and discuss something that I had mentioned in video 10, where I had made the statement. I'm not really certain why Eddie Van Halen had put his kill switch up here, because he had all the real estate in the world to put it down here if he wanted to. And then I had made a statement, well, maybe you would want to stay palm muted or something. But the whole idea of doing kill switch work is because you've just hit a note or you've hit a chord and you're not muting it. You're letting it ring out, and then you're doing your kill work. And I had completely forgotten. But the whole idea about Eddie having his kill switch right here, because he played the vibrato, he played the Floyd Rose, and it worked out perfect for him to, as he's doing his dive bomb work, as he's going diving down, he's able to do his he's able to reach up here and go boom, 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 boom. It's kind of like a train track. If you've ever heard of the train when it first takes off, if you're real close to the train tracks, if you're real close to the train, is if the locomotive and all the cars are sitting there connected, but then the first the engineer hits the gas and goes forward, it goes boom 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 boom, and you hear this incredible continuation from the main car all the way down the line. So for added drama there. So that would have been the reason he had that location right there. So on that note, if you're building a guitar that's Floyd Rose equipped, try to figure out how to engineer your kill switch in that location so that you've got good access to it. And it will be based solely on the length of the vibrato arm. Okay? So I can get that off the table. And continue moving forward. I'm not really going to talk about, because, let me check the time. Yeah, because of time, we're already at 10 minutes. I'm not really going to talk about how to drill a hole, but I just found that it's easier, rather than trying to set up some sort of jig and do this with a router bit. I like the idea of just using a Forstner bit. And basically what that is a European hinge, like for a cabinet building. That is the exact size for European hinge installation. And because I used to build a lot of cabinetry, custom cabinetry and stuff. So I've had this for I've probably had this 35 years, had it forever. But I just drilled down just enough to make certain that I better be careful, I might scratch that guitar. But I just got it drilled down so that I would have room for the Tessie, as well as the wiring to go around the side. So now let's open up the box. And this is one of those tricky boxes. There's something about it where I think once you open it, you can't close it again. Yeah, let me pause. Okay, yeah, it's one of those boxes where it doesn't have a little tongue. Oh wow, yeah, that's like super, super, super soft. You get some free picks, which is kind of cool. So let's take it out and see what we got. Oh wow, long wires. The wires are much longer than the other one. Let's just do a quick side-by-side comparative of the kill switch I had. Bigger. And if we have time, I actually have my scale over there on the table, and we'll do a little bit of press analysis, but I'll just go straight to the finish line and tell you the one on the right is so nice. That's so sensitive. So even if you were doing like real delicate like jazz work, that might be something that you would be able to incorporate. This one was just way too stiff. And as I had mentioned to him months ago when I bought this, I was like, not all of us are like hardcore rock and roll metal heads where we're really banging on the guitar, but this will allow you to do real sweet, gentle work. It's great, beautiful. All right, let's get that aside. And yeah, this is I'm gonna go ahead and, well, I'm not gonna complain. Okay, well that I don't know, and I don't want to just pull on that to try to take it loose, but again, it's almost like okay, yeah, I'm gonna complain a little bit. That's incredibly tall. I mean, that wouldn't even go in a 1 3/4 inch body. If anything, I don't know. It's just the way designers are. They seem to not think through things like that. Let's look at how tall it is. So, me as the builder, I've got to now take this thing apart, disconnect these and resolder these so that I've got a shorter footprint. This would require for them to be crushed in there, this would require a 2 1/8 inch deep hole. I mean, it's almost like and there's a part of me, do they engineer this stuff into these things just to piss people off? I've seen that with a lot of the Asian products where everything is great right at the point where, well, how the hell am I supposed to get it in the body? know, let's just consider our situation here. So most rock and roll guitar guys, we're not playing, guitars that are 3 inches thick. So there you have it. Now I'll get to spend a good 45 minutes to an hour re-engineering something. I'm not going to take their switch apart, but I'm going to have to come in here and disconnect these and solder these on a straight 90 degree, and then look at it from the side. And after it's all said and done, the back of my guitar body will be about a half of an inch thick. So it's okay. I'll be able to work with it, but I see a lot of that type stuff in the Asian reproduction stuff. And here's something to be really careful about. Uh, I hope I don't have to delete this video because this kind of stuff puts me in a bad mood, and then I don't feel like building guitars anymore. But when you order these vintage reproduction type tuners, these are not Kluson. These are just these are Gato. But these shafts are not the original historical vintage height. They are a good eighth of an inch shorter, if not possibly a little bit more. The vintage guitars, if you're building that headstock, you, you want to be able to, like a Les Paul or something, you want to be able to taper the headstock, and you want the headstock to be getting much closer to 5/8 of an inch thick up in this direction and about 9/16 of an inch thick out here. But with this reproduction tuner, you have to make the look at that right there. This is a 9/16 inch thick headstock, and if I was to put this tuner on here, the little curvature in the shaft is actually below the actual ferrule. And that's what I meant by sometimes they engineer this, into these items just to get under our skin. So if you can find vintage items that are true reproduction, they're going to be accurate. So anyway, I'll stop. But it's just really frustrating when you're fighting things like that, and especially if you're trying to explain that to a client, why it's going to take you, much longer to do a job, or either why you're going to charge your client an extra $50 because you got 15 people in line and you're trying to run a store and a music store, and then you agreed to install this for $20, but now you're going to have to charge them 75 because of the engineering of that item. Now, that's not going to happen. I'm not going to do that to Art because I'm only building one guitar here. But this is a lot of the reason why I started doing my video series, is to let you guys know when you're getting ready to build something custom, and God forbid you're going to do it to try to make a living. Just be forewarned that a lot of this reproduction stuff from the Asian stuff is mostly just crap. Okay. All right. So let me. I'm not even going to pause. I'm just going to keep rocking and rolling. But it really does piss me off that you're ready to install an item. It's great. It'll work out, and it'll, as my little nephew used to say, it'll come out in the wash. Let it go. But nonetheless, I like it. It's a good item. Okay. Let me check the time. 18 minutes of turning into my dad. All right, let's see. Where do we want to go now? So I'm not going to talk about this anymore other than lay out all your perimeter lines, which is very important, and then just do your drill work accordingly. Otherwise, you might have made a statement, oh yeah, I can put this thing anywhere you want, but you might be limited to where the screw locations are, something like that. Okay? So, all right, so the next thing that I want to talk about, let me look at the table here. I was going to drill this on camera, but I'm not now because I don't really have time, and I don't want to risk getting a... Oh, I will say this. Once I did find that location where I want it visually, I just made a mark through the... I don't have a pointer, but just with a little pointer, I heated it up with a butane torch. I had this exactly where I wanted it, and I had the center of my little medallion marked, and I just did a kiss right there and melted the little center hole, and then I drilled through it so that once I put this up here and I had that temporary block in there, then I was able to come back with my pointer after I had that location drilled like that right there, and it's down, and there's a temporary block of wood under there. Now I was able to go through there and imprint exactly where I wanted the center of the Tessie to be. Now, and I'm going to have to continue to talk about this, but because I'm doing such a substantial size hole, I didn't want to drill the Tessie. I didn't want to drill this directly in the center of that. That would not have made any sense. So I offset the drill bit work, or the Forstner bit work. I offset it down because the Tessie switch is actually up here, very almost touching. Well, I offset it 1 millimeter, and I've got 1 millimeter clearance around the housing of the Tessie, so that gives me plenty of room for the wires to go around. So that's not where the Tessie is going to be located in the guard. It's going to be located right there. So just make certain that you engineer. So when I made that mark through there, I then divided the rough opening of the Tessie body and then in half, and then offset everything. And I drilled that a little bit lower in that direction right there. Okay, that ought to make perfect sense. If it doesn't make sense, just don't get overzealous and think that that's where your, well, that would have been a good way to explain it. That's not where it got drilled. It actually got drilled, it got drilled up above it, I believe. No, it got drilled below it just a little bit. Okay. All right, so now let me get this off the table. Get the Tessie off the table. Try to think happy thoughts and ask myself what we want to talk about next. Okay, the next thing would be, let's start talking about wiring. So I want to get this off the table, I think, because I don't want to start pulling on that tape and risk screwing anything up. The body's been drying for over a week. It hasn't changed since the last video, but it's got a good solid week's worth of dry time. And she was ready to be wet sanded like on Friday night or Saturday. So the fact that it's actually Monday right now is even better. So it's even more cured, because see, the whole idea about the Nitro Cellulose lacquer, it actually shrinks a little bit, and according to how thick you sprayed it, it can shrink quite considerably. So you want to make certain that it's truly ready to sand. Okay, let's talk about just my setup. And the whole idea about when you're getting ready to build just one single guitar, you have to ask yourself, oh man, do I want to build, this acrylic template and this template and all that stuff? I would say not necessarily. I wouldn't really recommend that. If you're just going to build one guitar, I would say probably just build everything from the body. But if you've never done it before, I would definitely recommend going to like your big box hardware store and getting some poplar, which is fairly soft wood, whatever your location is. I love working with poplar. It's really affordable. And build one 3/4 of an inch thick out of poplar so that you just get a feel for all the order of operations. And at a minimum, you're going to figure out how, oh wow, I shouldn't have drilled this location, or I should have waited on machining this, or I should have, before I did all the paint work, I should have built my wiring harness on the actual body. Like even if it were, really nice select wood, and you didn't even elect to build a poplar guitar, well, you could do all this stuff in the rough body before you do any of the final machine work. But it's really tempting, and it's difficult to restrain yourself from, once you start machining the body, you can't help but kind of want to go ahead and do a lot of the finish work. And so just do the best you can to hold yourself back from getting it too nice. You want to work your way to the finish line and never really do any of the really fine, beautiful work until is you want to hold off on that stuff as long as you can. So on that note, as I say too often, maybe build one out of poplar, and then, or build it out of plywood, 1/2 inch plywood, and then if you're not ever going to build one again, well then maybe paint it and turn it into a clock and hang it on the wall, or just turn it into art and go from there. But in my situation, I knew I was wanting to. Well, actually, the first one I built, it was for a client that I knew, because I had built a lot of guitars, but I had not built this footprint yet, and I had no idea about how I was going to go about machining all of my pick guards and stuff like this, because this is not something you can buy off the shelf. Nowhere. Period. You're not going to find this anywhere, because it's a completely different size. It's longer. It's fatter. This is being a 58. It's a different size than your 76. They're very pointy and they're much shorter. So I knew that I had to machine all of these templates in order to have something to actually work from. And whether it's a 25.5 inch scale or a 24 3/4 inch scale, et cetera, et cetera. So just be prepared that in order to build a guitar from scratch, you may end up building 2 or 3 guitar, almost the time that it took to build 2 or 3 guitars in order to finally get to that point where you're doing that last one. I won't go into this too much, but let me check the time. 26 minutes. Yeah, I probably just need to slow down a little bit and talk about how I set it. What did I do first? I did this first. And because I wasn't exactly certain how long these were going to be, because the kit that I ordered, that was the only material left over, about 8 inches, 9 inches in length, and I had bought an additional output jack. And if I don't show it, that's kind of how I do my output jacks. I'll talk about that in a minute. But that's all I had left over, so I couldn't just scrap cut these and end up risking, oh my gosh, I wasted 2 inches on each one, and now I don't have enough to do my jack, or either the jack output jack's going to go in there and it's going to be real short and real tight. So the whole idea is, I like the idea of leaving myself plenty of room so that I can kind of curl around things like this, and also from a functional standpoint, if and there's a fine pencil line right here. This is the exact location of that jack, so you can see I've got plenty of room up in here to take this cover loose and actually pull that jack out as far as that right there if I need to. I wouldn't need to, but if I did, I would be able to still pull that out and see it. And then once I push it back up in here, I would make certain that I didn't have it in a bind. I would have it twisted in the right orientation, so everything, just didn't run the risk of making contact with a hot circuit or anything. Okay, and the actual this is your neck volume, your bridge volume, and obviously your master tone. Everything about the master tone, it's actually the master tone and the output jack is an individual circuit from the 2 volumes until you wire the whole guitar, because see, these will have to be put into the finished guitar, and then all the final solder work is done, because the way these control cavities are, well, you guys obviously, well, some of you don't know. In other words, it's not a Fender Strat or a Tele. You have to feed these wires through, these channels, such as that right there. And then obviously, once you flip it over, in case you've never seen the inside of an Explorer, these wires will then be coming out of that location right there, and it's a very, very tight control cavity. I mean, it's insanely tight. You have to be really aware of everything that you're doing as far as links and stuff like that. So, and I won't go into detail about which one is which, but I might a little bit. But basically, doing soldering work, building a wiring harness, it can be really frustrating if you don't have the right equipment, but it's also very therapeutic. I enjoy building my own harnesses, also because as you get a little bit better, you try to do things like minimize your solder joints, only use what's necessary. That's a ground wire because in your potentiometer you're always grounding. Well, for this guitar for volume, you're grounding this lug and you're grounding that lug to the body. But my theory is, why bend it over and ground it when I can just feed that ground wire through there and knock out 4 points in one wiring run. The ground on that back, that lug, manipulate over here, ground there. Solder right here and solder right there. And the whole idea is to use a silver solder, a really high quality for electronics. I do like to use a little bit of flux. I use a 25 watt soldering iron on the back of the potentiometer, and I try not to use the 25 watt on that. But if I do, I'll use a little alligator clip. But if I do use the 25 watt, it's a very fast solder right there. But typically you want to use a 10 watt on that. Now, one thing I will cover here with your capacitors, I never knew this when I first started building a long time ago, and I only found out something like 5 or 6 years ago that capacitors have an orientation. And I never knew that, when I first started. And a lot of people claim that it's not. Well, I'm not going to say that. A lot of people just don't realize that they are directional. And what it boils down to is, let me pause and get a piece of paper. Okay, I'm only going to just repeat what I've heard other professional techs talk about. I don't really understand a lot of this stuff, but I can understand it. I understand it enough to just show you the drawing. If you have your capacitor here, you have one side that is preferential to be the ground side, and one side which is preferential to be the hot side. And if you were to dissect that capacitor, on the ground side, the leg goes in and it hits this little barrier here. This a little it's like a little bucket of foil. Okay, and then the positive one, the one that would be preferential for positive, would come up and go into the capacitor, and then that wire would just go into the middle. And apparently they don't connect in there, but this positive line goes in and it's just shielded by all of this foil. And that's all I can explain. And don't think that just because you see the writing on there, that doesn't exactly see. I made that black magic marker on there because I tested this one and I determined this to be the side with the foil, and then that would be preferential for the ground side. But it could have been, just because it had the writing on there, it could have been opposite. Now, and I'm just going to stop. It may be that they have a positive or negative on some. I don't know. But all I do know is that the way you can test it is, well, I'm not going to talk about it. Just do some research. Just do some research on and look for videos on how to determine the orientation of a capacitor. And after it's all said and done, if you had this installed improperly and you had your guitar plugged into your amplifier and your amplifier was on, if you not that you're playing the guitar, but it's just the volume's up, the amplifier's on, if you've got a massive hum, well, you just reach down and you just touch the capacitor, and if all of a sudden you hear it get louder or hum a little bit warmer, then you realize that your capacitor is in backwards. but you should be able to reach down and touch the capacitor, and you're not grounding out at all. Okay, so just keep that in the back of your mind, and do some research. There's a couple of videos out there that I've watched before I did this video, just to try to explain to you. Don't just grab this. Don't just grab this up and just solder it in based on what you want to see. That might be wrong. Okay. Okay, so probably not a whole. Yeah, I'm not going to go into any detail as to why I connected at a certain lug or anything like that, because I don't have the time. But one trick I will show you here, um, if you're working on building a output jack, well, don't just lay it on the table and try to fight the little thing on the table. You can do things like this right here, where now you can. Okay, you've got this raw output jack, and you're going to do all the solder work. Now you can actually turn it, and you can do all your soldering work just so with so much ease. So do things like that, little cheaters. And I had even thought about making a bracket, something where you could like clamp that. But if you've got at a minimum, just take a board and do a straight line and make certain that you get these lined up perfectly, because the control cavity for either the Telecaster, or either the Flying V, or the Explorer Replica, Explorer, whatever, and then probably a few other designs out there. The control cavities are really tight. You know, you're extremely limited to your footprint and the direction of the wiring. And I've already covered that enough to let you know. Just think through the design. And probably one thing I could have done, I could have put some heat shrink wrap right there, just to say, be careful, to protect it. And I could have put some heat shrink wrap on this outside cable here. But when I'm putting all this together, I'm just going to make certain to keep it all clear and away from everything. But it turns into a really busy little cavity after it's all said and done. Okay, I'll take the time. This works well because your potentiometers are sticking through. You don't want them getting damaged. So just use some quick grips and turn it into a little coffee table, and then you can do all your work here. Again, I used a 10-watt soldering iron on all the lightweight joints, and a 25-watt soldering iron on the soldering to the body with a flux. Makes all the difference in the world. And I like the idea of having a brass brush if I'm getting ready to do solder work on this potentiometer. I like the idea of cleaning it and just making certain that you got a good clean surface there. And then if you're going to ground, if you were going to, let's see, where would you be going? You would be going on this side right here. Well, maybe put a little bit of flux right there. Well, maybe that's where I would put my flux, right there. And then I would probably go ahead and connect and do this hot join first. Yeah, this is pretty important. I would go ahead and do this. I did that. Okay, if this is in there, I would go ahead and make this soldered connection first. Then I would just press this down, and I've actually got to a point now where if I can't find something that has, some weight to it or something like that, I've actually been using masking tape. Sometimes I'll use masking tape to tape something down in place, or either put a little block of wood up here and clamp it, and then put masking tape on that to assure that it holds it nice and flush with what it is you're doing. Because you want to have your left hand and your right, well, you've got to have your left hand and your right hand free, but you don't want this thing floating around and then trying to push it down. You want it exactly in the location that you're going to be doing your solder work, and that will give you a really beautiful professional solder joint. Okay. All right, so practice, and I don't know if I talked about this at all. I don't really have time to talk about it, other than basically I like using the ground wires Yeah, this is pretty important. Rather than just trying to do real sloppy groundwork, do a little starter wire, and I'll go ahead and solder that ground wire in there, and then I'll bring it up and just leave it loose, and then I'll do all the other solder work, and then the very last thing that I do. Oh yeah, okay, yeah, you can see it right there in the camera. See how there's the little ground wire right there? And then it just runs out here, and I cut it off that to that length right there. And then the very last thing that I do is put a little bit of flux on everything, and then with a 25-watt iron, because I want this to be really fast, I use a 25-watt iron, and I will solder all that together. And then other wire, this other wire is loose, but then what I'll do is I'll roll it over, and then I'll just solder these two wires together. So it made a real nice full connection, kept it real nice and stiff. You don't run the risk of any you don't run the risk of any movement. I'm sorry, I'm talking into the camera. I apologize if that was loud. I wasn't thinking about what I was doing. But you don't run the risk of any. This little wire is really stiff, so it helps hold everything in place. And that's what I meant by you couldn't do a Tessie kill switch, you know, back here, because that wire is not moving, and you'd have to redesign all that stuff. We'll start talking about that again. Okay, I'm gonna watch this video and see if it was even worth uploading, and I hope it was. I don't do a lot of soldering work, and I don't build a lot of harnesses, but I typically do like to build the harnesses for the guitars that I build. Um, just, if anything, to continue to be a part of the actual build, but also to make certain that I got really good solder joints. Because where I was going with this is very important that after you do your solder work, it needs to be very, very shiny. And if it's real dull and very gray and real blotchy, that's a really lousy solder joint. And where I'm going with this, see, it only took just a very small dot to connect those two right there, which or connect the one on the top, which was all the major work was done on the two on the bottom. So I left that heat shrink wrap loose so I could show this in the camera, but now I can slide that up there. Oh, I know why I did that. So that when this guitar goes to California and whomever installs the pickups and they look down and they can verify, okay, yeah, he's got a really nice shiny join right here, a beautiful shiny join here, but he's got a shrink wrap on there. I don't want him to fear or her to fear, oh God, he might have done a sloppy join here. But with this video, he or she can see that I've got a really beautiful solder joint back there. So they should be very confident in 30 minutes worth of work just wiring in their pickup, which their pickup wire will be coming in. Okay, when I ship this guitar, my wiring will be finished to the middle of the potentiometer neck, and then now I'm holding the bridge. The only thing whomever installs the pickups will have to do is solder their pickup wire, do their ground, and then they will be connecting to the outside lug. So the outside lug for the bridge pickup volume, outside lug for the neck uh, volume. Okay, that ought to make perfect sense. So in other words, the only two lugs that will be remaining will be the outside lug here and the outside lug there. And I typically go ahead and just clip this lug off because it's unnecessary. So in other words, there are no other lugs that would be open, so that you'd have to figure out where the volume goes or the pickup wire goes. Okay. So the three-way always connects in the middle on the Gibson product, and I think it's different on the Gretsch. I have to look at the schematics before I do it, But it's really interesting. There's a lot of different ways you can do wiring, and I'll be the first one to admit I really I don't know. I don't know some of the tricks, uh, but it's cool to get to learn and not only just build your own guitar, but you can save a little bit of money by building your own harness, but not much. If you can find your harness out there that's pre-made, even if it's 80 to 150, $200, and just buy it. But our dilemma here was, see, we have to have a taller shaft. And I could have bought the Explorer or the Flying V harness, but it would have been a short shaft because it would have been going through. Just a little pickup guard, because like the Flying V, you know what I'm saying. I'm sorry, on the Explorer body, it's just much more narrow. It's a very thin topped body right there, and it's shorter. But since I build my guitars so substantially thick in that location, I have to have a tall potentiometer, and nobody out there makes that wiring harness for a Les Paul type potentiometer shaft, real tall shaft. This is called the long shaft. I think that's 3/4. It might be 7/8 of an inch, and this short is 3/8. Okay. All right. Again, don't trust me 100%. Do your own research when it comes to doing your wiring harness work. But yeah, just that. Just dive into the videos. There's some great work out there. And let me check the time. 46 minutes. Yeah, I'll just kind of go off a tangent here. About the last 2 or 3 years, I've been wanting to build my own amplifier. I've never built an amplifier before, and I really have no idea. Well, I used to not have any idea where to start, but I've got an amplifier that I sold to a buddy up in Franklin, Tennessee. It is a Fender Blues DeVille, and it is the very first one they introduced back in the early 90s, and it's the one made in USA. And I come to discover that that amp is a phenomenal platform to kind of not even gut it, but to go in and pull a lot of the caps and a lot of the electronics in it, and you can turn it into like your own Dumble. And I've thought about giving that guy a call and see if he would sell that amp back to me, and then do the Dumble mod, because from what I can tell, it would make more sense to just buy a really nice like Fender Tweed Deluxe or something like that, or pick your poison, whatever amp you're wanting to build, and then just modify it. I don't really want to build an amplifier from scratch because I'm not really talented. I'm not qualified to know how to assess all the values, but I do know that would be a real cool project to tackle. And there's several guys on YouTube that show you kind of exactly how to do it. And I think you can even buy the actual capacitors and resistors in a kit, and possibly even the transformer. So if I could pull all that off for under $1,000, and then you got a phenomenal amplifier that's really beautiful, because it's the blonde Tolex, which is really rare for that amplifier. And I just love the footprint of it. So anyway, I may do that. If I do that, I might do that in a video series as well, if I get the time. Otherwise, I hope I didn't waste anybody's time, as I always say. But I'm just kind of looking at the table and asking myself if there's anything else we need to talk about. I don't think so. So what I'll do is lay the guitar back up on the table for effect. And then probably what I'll do is use that as my closing picture for the screenshot, and put the pick guard up there. So it kind of makes it nice to show what it is that the video is going to entail. And I'll just put a little capacitor up there. That way, that might intrigue someone to realize that, hey, he's probably going to be talking about electronics in this video. So I appreciate you guys dropping in. I have no idea the next video, but the next thing that's going to happen here is the final wet sanding, and then I'll be installing that harness, and I probably won't do that on video just for fear of screwing something up. I got to be really focused on that and not risk, damaging the guitar or burning a hole in it. All right, appreciate it. I'll see you guys in the next video.